Not all quadratic equations can be solved easily through factoring. Some will require a new technique. This technique we're going to call completing the square. Today we're going to simply look at leading coefficients that are equal to 1. So let's take an example. X squared minus 6x plus 7 equal to 0. Notice we cannot factor x squared minus 6x plus 7. So what we're going to do in completing the square is to move the constant term to the right side. Now this is different in our factoring. Remember, in our factoring we wanted it equal to 0. This time we don't. So we're going to subtract 7 from both sides. We get x squared minus 6x equal to negative 7. Notice I've left a space between my linear term and my equal sign. To fill this space, we're going to take the linear term, coefficient, we're going to divide it by 2, and we're going to square it. So negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3. Squared is positive 9. Remember, in equations, if we do something to one side, we have to do it to the other. So we're going to add 9 to the right side. So now our equation looks like x squared minus 6x plus 9 equals 2. The third step is to go ahead and factor the left side, or the trinomial. Factoring this, we get x minus 3 and x minus 3 equal to 2. Notice our two factors are the same because we've completed the square. We can rewrite this as x minus 3 squared equals 2. The fourth step is to go ahead and solve by taking the square root method. And all the square root method tells us to do is to take the square root of both sides. If we take the square root of a square, we end up with x minus 3 equals, remembering, if we take the square root of a number, we can have the positive or the negative of that number. We're going to solve for x by adding 3 to both sides. So we end up with x equals 3 plus or minus radical 2. We cannot add these two together, so we're going to leave it as 3 plus radical 2. And there's our solution. Notice we have two solutions. We have 3 plus radical 2 and 3 minus radical 2. Notice our degree is 2. Two answers, degree of 2. In example 2, we can look at a problem that would be factorable, but completing the square, to show how completing the square works and how you can simplify your radicals at the end. So we have x squared minus 6x plus 8 equals 0. Remember, this is factorable because we could have negative 4 and negative 2 to give us a negative 6. To complete the square, I'm going to move my 8 to begin. So x squared minus 6x, leave my space, equals negative 8. Take my negative 6, dividing it by 2, and squaring. Negative 6 divided by 2 is negative 3, squared is 9. So I'm going to add 9 to my space and to the right side. I can go ahead and simplify. So I get x squared minus 6x plus 9 equals 1. And I can go ahead and factor. I get x minus 3, x minus 3 equals to 1. I have two terms that are the same. These will always be the same. So we get x minus 3 squared equal to 1. Taking the square root of both sides, I get x minus 3 equals plus or minus 1. Solving for x, I get x equals 3 plus or minus 1. Notice these are both whole numbers, so I can go ahead and add them together or subtract them from each other. So my two equations become x equals 3 plus 1 or x equals 3 minus 1. Simplifying each of these expressions, I get 4 and 2. Notice I have two answers. My degree is 2. And there's my solution. For example 3, we're going to change it up slightly. We're going to still have a leading coefficient of 1, so we're going to start with x squared. But this time, we're going to subtract 3x. And let's set it equal to 10. Notice this number now is not even, it is an odd. But we're going to do the same process. We're going to take this number, negative 3, we're going to divide it by 2, and we're going to square it. We can't simplify negative 3 over 2 any more than it is, and we're going to leave it in fractional form. Squaring it means that we're going to take negative 3 halves and multiply it to negative 3 halves. That asks us to multiply the numerators together and multiply the denominators together. So negative 3 times negative 3 is 9, and 2 times 2 is 4. So we're going to add 9/4 to both sides. So I end up with x squared minus 3x plus 9/4 equals 10 plus 9/4 is 49/4. The way we did that, we can write 10 over 1. To add fractions, we need a common denominator. Common denominator between 1 and 4 is 4. So what do you multiply 1 by to get 4? 4. So you multiply 10 by 4, and you get 40 plus 9/4. And 40/4 plus 9/4, we add the numerators, leaving the denominator the same. Now we can go ahead and factor this. So we get x minus 3 halves and x minus 3 halves equals 49/4. You may ask the question, wow, how did you get that so quick? Notice the negative 3 halves that we squared up here is what we ended up with down here as our constant. It will always happen that way. If we go back to example 2, notice negative 6 divided by 2 was negative 3. And negative 3 is what we ended up with down here for our factorization. So we can write this as x minus 3 halves squared equals 49/4. Take the square root of both sides. So we get x minus 3 halves equals plus or minus square root of 49 is 7. The square root of 4 is 2. So we get plus or minus 7 over 2. Solving for x equals, add 3 halves over, we get 3 halves plus or minus 7 halves. Notice these are two real numbers, so we can add them together. So we get x equals 3 halves plus 7 halves, and x equals 3 halves minus 7 halves. 3 halves plus 7 halves is 10 halves, or 5, and 3 halves minus 7 halves is negative 4 halves, or negative 2. And there's our two solutions. We can look at one more for good measure. I like good measuring. So example 4. let's give us x squared plus 5x minus 8 equal to 0. Here I'm going to move my 8. So we get equal to 8. I'm going to take my 5, divide it by 2, and squaring it, I get 25/4. So I'm going to add 25/4 to both sides. Notice I'm always adding, doesn't matter what our numbers were, because when we square a positive or a negative, we get a positive. I'm going to go ahead and factor this, since I know what it factors to, my 5/2 squared equals, adding these two together, I have 32/4 plus 25/4, so I get 59/4. I'm going to take the square root of both sides. So x plus 5/2 equals plus or minus the square root of 59. I know the square root of 4 is 2. I can go ahead and simplify this by subtracting 5/2 from both sides. So I get x equals negative 5/2 plus or minus the square root of 59 over 2. Notice my denominators are the same, so I can put my two numerators over that common denominator. Negative 5 plus or minus the square root of 59 over 2. Since I can't simplify the square root of 59, I am finished. And that is completing the square. To review, we're going to solve quadratic equations with completing the square. We moved the constant term to the right side. We divided the linear term by 2 and squared it, and added that to both sides of my equation. I then factored the left side. Using the square root method, I solved for x, and then I solved for x again if there was a constant with it. So I added 3. And that concludes our solving quadratic equations.